We are studying digital signal processing, and in that we have started the lectures on Z transform. In previous videos we have studied the concept of Z transform, what is Z transform, and we have calculated different types of Z transform, for example causal, non-causal sequences, and we have formulated various relations in Z transform, and we have also studied the properties of Z transform. So let us study what is meant by inverse Z transform. What we did in Z transform, we have converted a Z domain signal, N domain signal into Z domain. We have converted Xn to Z domain. Now we can obtain this Z domain signal back to time domain signal. Z transform converts time domain to Z domain, and inverse Z transform converts Z domain to time domain sequence. Now here are different cases are there in inverse Z transform. So we are studying this particular case when inverse Z transform when poles are distinct and real. So this is our case. For complex poles, okay, there is a different kind of discussion. Now x of z we have, x of z is given like this. So it is n of z divided by it is d of z. So this is the polynomial form, and this polynomial is having order m. So I will write, so polynomial order is m. It is mth order polynomial, and this polynomial of denominator is polynomial of order n. Now according to the order, this m and n, there are the different cases to solve the inverse Z transform of this. Say when this m is greater than n, or let us take m is less than n. Say this m is less than n. It means the order of numerator polynomial is less than the order of denominator polynomial. So how to solve the inverse Z transform in this case? So we can express this x of z as, say x of z is n of z numerator, n of z divided by z plus p1. We have to express, in this case you have to express this x of z. What is x of z? X of z is given Z transform, and we have this, we have to arrange, we have to bring this in this form, z plus p1, so it is z plus p2 into z plus p3 plus so on plus z plus pk. What is pk? pk is the kth pole. Coefficient of this are called zeros, and coefficient of this are called poles. Okay, so we have to bring this equation into this form when this is the case, and using partial fraction. Now here we can use partial fraction method. Partial fraction method. So x of z is equal to, it is c1 divided by z plus p1. Okay, z plus pole 1 plus c2 divided by z plus p2 plus c3 divided by z plus p3, and so on. So let us say it is cn and it is z plus pk. Okay, now we have to find the values of c1 and c2. So we can find C1 is equal to, it is Z plus Pk. This is general equation we are writing, into x of Z at Z equal to minus Pk. When we take this value minus, so this becomes 0 and we'll get a value for C1 out of this equation. So by using this method, we can find the coefficient, and after that we can take inverse Z transform of the equation x of Z and we can obtain the time domain equation xn. Now second case, if the order of numerator polynomial is greater than order of denominator polynomial. Okay, so what is the case? Okay, so x of Z is written as x of Z is equal to, it is q plus n of Z divided by d of Z. Okay, and this is having remainder of what? Long division method remainder, and this is divisor, and this is quotient. Okay, so what we have to use in this case? We have to use long division method. Remember this one difference: when x of Z is given and you check the two polynomials denominator and numerator, if the order of numerator polynomial is greater than the denominator polynomial, then you use this long division method and you will obtain these three things. And when you obtain m less than n, when you obtain this, at that time you can use this method. You can use partial fraction method. Otherwise no. If you are not getting, once it is perform long division, again perform the long division method by using these terms and obtain this case and go for this one. Okay, one more method is there, that is the residue method. We'll discuss it later. Let us solve one example by using partial fraction method. Before solving one example on Z inverse Z transform, we should remember the Z transform table so that we can find the time domain signal from Z domain. So in that I have picked up some important relations which we have used in finding the Z transform of time domain signal. So this x of n is the time domain and this is the Z domain. So we have Z transform of this and is the region of convergence. Tau of n has Z transform 1, entire Z plane is the ROC. U of n is Z transform 1 divided by 1 minus Z raised to minus 1. If you simplify this, if you take 1 minus 1 by Z, and if you simplify this, you will get this. So this will help to understand, or directly you can find the Z inverse Z transform if you know these relations. Here ROC is mod of Z greater than 1. A raised to n U of n, 1 divided by 1 minus a raised to Z minus 1, and you can obtain this. Here mod of Z is greater than 1. Now see the second case. Here a raised to n U of minus n. What's the difference? The difference is here. So this one. So here mod of Z is greater than a when U of n, it's a positive right-sided unit step sequence. Here it is left-sided unit step sequence. Therefore, so mod of Z is less than a. Okay. When this is given, it means that it is left-sided unit step sequence. The next important Z transform of a raised to n U of minus n, this one, and this n into a raised to n U of n. A Z raised to minus 1, 1 minus a Z raised to minus 1 square. Simplify this, you will get this. And mod of Z is greater than a, and this, in this case, mod of Z is less than a is the ROC of this one. Apart from this, there are so many important Z transform you can add up to this. Let us solve one example on inverse Z transform. Our first example is, so it is unsolved example from John J. Prokis digital signal processing textbook. So x of z is given as 5 z raised to minus 1 divided by 1 minus 2 z raised to minus 1, 1, so 3 minus z raised to minus 1. Okay. So I found a simple way to simplify this first, because we can't proceed with z raised to minus 1. There are so many methods used to make it positive power of z. So one better solution is, let us substitute, put z raised to minus 1 equal to x. Okay. And here the order of this denominator is greater than numerator. We can use partial fraction method in this case. Okay. So by putting z equal to z raised to minus 1 equal to s, so this becomes x of z is equal to 5x divided by 1 minus 2x 3 minus x. Now it looks simple. So we can use partial fraction method using partial fraction method. So we have to write this 5x divided by 1 minus 2x 3 minus x is equal to, let us take c1 divided by 1 minus 2x plus c2 divided by 3 minus x. Let us obtain the values of c1 and c2. So it is c1 is equal to, just cross multiply this, c1 and c2 and equal to this 5x. So c1 is equal to so 5x divided by 1 minus 2x 3 minus x is equal to c1 divided by 1 minus 2x plus c2 divided by 3 minus x. To obtain the values of c1 and c2, just cross multiply and equate this equal to 5x. So it is 5x is equal to c1 multiplied by 3 minus x plus c2 1 minus 2x. Okay. If you substitute as x equal to 3 in this, okay, put x equal to 3, you can obtain the value of c2. So it is 5 into 3, c1 into 0 plus c2 1 minus 2 into 3. So it is 15 is equal to 0 plus 6 minus 1 is 5. So it is 5c2. So it is minus 5c2. So what we'll get? We'll get c2 is equal to 15 divided by minus 5. So it is minus 3. So we got c2 is equal to minus 3. So let us find value of c1. So we have 5x is equal to c1, it is 3 minus x plus c2, so it is 1 minus 2x. So substitute x is equal to 1 by 2. If you substitute this here, x is equal to 1 by 2. So it is x is equal to 1 by 2 So it is 5 into 1 by 2 is equal to C1, 3 minus 1 by 2 plus C2, 1 minus 2 into 1 by 2. So this will become 0. So 1 minus 1 is, it is equal to 0. So we have, it is 5 by 2 is equal to C1. So it is 6 minus 1 or 2. It is C1 is equal to, it is 5 by 2 is equal to 5 by 2. So C1 is equal to 5 by 2 into 2 into 5. So this cancels and it is equal to 1. So C1 is equal to 1. Let us substitute the values. So it is, we have C1 is equal to 1 and C2 is equal to minus 3. So our equation is, so it is 5x divided by 1 minus 2x, 3 minus x is equal to 1 divided by 1 minus 2x minus 3 divided by 3 minus x. Okay, and this equation is equal to 5x. Okay, let us simplify this first. 3 minus x will make it 1. Okay, just divide it by 3, numerator and denominator. If we divide by 3, so what we'll get? So this will cancel. So this is going to cancel 3, 3, 1. So it's 3, 3, 1. So we can rewrite this as, so it is 5x by 1 minus 2x into 3 minus x. This is equal to nothing but x of z. Okay, x of z. So it is 1 over 1 minus 2x minus 1 divided by 1 minus 1 by 3 x. So we have this equation. Now let us substitute x equal to z raised to minus 1. We had replaced z raised to minus 1 using x. Now putting back x is equal to z raised to minus 1, we can obtain our x of z. So x of z is equal to 1 minus 2 z raised to minus 1 minus of minus 1, 1 minus 1 by 3 z raised to minus 1. Okay, now we can find inverse z transform of this equation. Now remember this Z transform table. So it is directly Z transform of a raised to n u of n. Okay, so it is 1 over 1 minus a. Okay, now it is 1 minus a, it is 1 minus 2a, it is according to this relation. Okay, so we can directly write this as, so it is 2 raised to n u of n. Okay, sorry, we have to write it is x of n equal to, so it is x of n is inverse Z transform of this. So it is 2 raised to n u of n minus, this is also according to this relation Z transform. So it is 1 divided by 3 raised to n u of minus n. Sorry, it's not u of n minus n, it is plus n, because both are causal sequences. We can check the region of convergence, and because 1 by 3 is less than 2, therefore the ROC of this sequence is mod of z should be less than 2. Okay, its ROC is mod of z greater than 2. Okay, so the x of n is a causal sequence. It is right-sided u of n. This is right-sided u of n. Therefore, it is a causal sequence. Let us solve one more example on inverse Z transform. It is also from John J. Prokis textbook. It is unsolved example. So it is example number 2. Find inverse Z transform of x of z equal to, so it is 3 divided by 1 minus 10 divided by 3 z raised to minus 1 plus z raised to minus 2. Okay. Now here also power of z is negative. Now we have to find any suitable option to make it positive so that the solution will be simple. So I'm going to tell one simple method to make it positive. Let us multiply denominator and numerator by z square, so it will become positive. So it is x of z is equal to 3z square divided by 1z square minus 10 divided by 3 z raised to minus 1 into z raised z square plus z raised to minus 2 into z square. So what we can obtain from this? So it is 3z square. So it is z square simply minus 10 divided by 3. So it is minus 2. So it is minus 2 plus 2 minus 1 is 1. So z simply, and here z raised to 0. So it is 1 simply. Okay. Now let us factorize z square minus 10 by 3 z. Let's rewrite again. So it is 3z square minus 10 by 3z plus 1. Now we have to find factors of this. Factors. So what will be factors? So it is z square minus 10 by 3z plus 1. So this can be like this, minus 1 by 3 and minus 3. So it will be minus 10 by 3. Okay. If you cross multiply this, you will get minus 10 by 3. So factors will be, so it's a z square minus 1 by 3 z minus 3z plus 1. If you take common, so it is z minus 1 by 3, so minus 3 common, so it is z minus, so it is minus outside, so it will be 1 minus 1 by 3. So our factors will be so z minus 3 and other bracket z minus 1 by 3. Okay, let us simplify x of z by using partial fraction method. So x of z, okay, we have, so it is 3z square. I am rewriting it again. So it is z square minus 10 by 3 z plus 1. Okay, let us take z here. So we can write this x of z divided by z is equal to simply 3z. We are writing like this, we are taking z here. So it is z square minus 10 by 3z plus 1 is equal to, now we have to write this equal to partial fraction method by using partial fraction. We can write this 3z equal to, now, so it is 3z divided by z square minus 10 by 3 z plus 1. So this is equal to, so it is c1 divided by divided by z minus 1 by 3 plus c2 z minus 3. Let us find the values of c1 and c2. So it is 3z equal to c1 into z minus 3 plus c2 into z minus 1 by 3. If you put z equal to 3 here in this equation, put z equal to 3, what we'll get? We'll get first term c1 term 0. So it is 3 into 3 c1, 3 minus 3 0 plus c2. So it is 3 minus 1 by 3. So it is 9 equal to 0 plus, so it is c2 9 minus 1 by 3. So it is 8 by 3 c2, it is 9, and c2 is equal to 27 by 8. So this is our c2 value. So let us find c1. We can find here itself. So it is 3z equal to c1 z minus 3 plus c2 z minus 1 by 3. Put z equal to 1 by 3. So it is 3 into 1 by 3 c 1 by 3 minus 3, and here it is z, so it is 0. So it is c1 9 minus 1 over 3, and this is 1. So c1 is equal to, it is 8 by 3 1, and c1 equal to 3 by 8. So it is minus, okay, it is minus 9. It is minus 9 plus 1, so it is minus 3 by 8. So let us substitute in main equation x of z, or z equal to minus 3 by 8 z minus 1 by 3 plus 27 by 8 divided by z minus 3. Now let us send this z to the side. So it will become x of z equal to minus 3 by 8 z minus 1 by 3 plus, so it will be 27 by 8 z divided by z minus 3. Okay, you can write this right side in terms of negative powers of z. Now how you can write this in terms of negative powers of z? Okay, you can write like this. It is 3 by 8 divided by with z minus, sorry, so 1 minus 1 by 3 z raised to minus 1. If you multiply this, if you cross multiply this, so z raised to minus 1 is 1 by 3 z. If you do this, you can get z here again. So it is plus 27 by 8 divided by, so it is 1 minus 3 z raised to minus 1. Okay, now we can find inverse z transform of this term. So x of z is equal to minus 3 by 8 1 minus 1 by 3 z raised to minus 1 plus 27 by 8 divided by 1 minus 3 z raised to minus 1. Okay, What is the inverse Z transform of this? Inverse Z transform. By using the relations, we can write, we'll get x of n of x of z. It is equal to, so minus 3 by 8. So it's a coefficient. And here, so this term is, so 1 by 3, positive 1 divided by 3 raised to n. Okay, so a raised to n, Z transform of a raised to n is equal to 1 divided by 1 minus a. So it is minus a is present here into u of n. Okay, plus, so 27 divided by 8 is just a coefficient. Okay, and this term is minus 3. So it is minus 3 raised to n u of n. Okay, here u of n will be minus. Why? Here, if you write this term, this is equal to 1 minus 3 by z. So this z term is greater than 3. Magnitude of z should be greater than 3 to get finite value this of this. Okay, the equation, this equation should attain a finite value. Then it has a region of convergence. When this part will attain a finite value, when the value of magnitude of z is greater than 3, at that time this is possible. Okay, but in this case, so magnitude of z should be less than 1 by 3. So that is the difference. Therefore we are getting here positive u of n, and here, so it is negative u of minus n, so left sided. So this portion is causal sequence, and this is non-causal sequence. It's a left sided sequence.